For thousands of years, one star has stood out above all others. A deep red light burning from the shoulder of Orion. Ancient civilizations watched it carefully. Sailors used it to navigate. Farmers linked it to changing seasons. Myths and legends grew around it across nearly every culture on Earth. Unlike the cold white stars scattered across the sky, this one seemed different. Alive. Pulsing against the darkness like a cosmic heartbeat. That star is Betelgeuse. One of the largest and brightest stars visible to the naked eye. But beneath its calm crimson glow lies something violent. Something unstable. And in recent years, astronomers realized that Betelgeuse is behaving in ways no one expected. The star has begun changing. Brightening. Dimming. Shifting unpredictably. At first, scientists assumed the fluctuations were normal. After all, Betelgeuse is a red supergiant, a class of stars known for instability. But this was different. The patterns no longer matched existing models. Something deeper appeared to be happening inside the star itself. And suddenly, one terrifying possibility entered the conversation. Could Betelgeuse be approaching death? To understand why astronomers are paying such close attention, you first have to understand the scale of this object. Betelgeuse is enormous. So enormous that if it replaced our Sun at the center of the solar system, its outer atmosphere could stretch beyond the orbit of Mars. Some estimates suggest it might even approach Jupiter's orbit. Inside that volume could fit hundreds of millions of suns. Yet despite its colossal size, Betelgeuse is surprisingly cool compared to smaller stars. Its lower surface temperature gives it the distinctive reddish color visible from Earth. But cool is misleading. Betelgeuse radiates tens of thousands of times more energy than our Sun. And unlike stable stars, red supergiants live chaotic lives. Inside Betelgeuse, nuclear fusion has been raging for millions of years. Hydrogen became helium. Helium became carbon. Carbon became heavier elements. Layer after layer of fusion formed deep within the star like gigantic burning shells stacked on top of one another. But massive stars do not age gracefully. As they approach the end of their lives, their internal structure becomes unstable. The core contracts violently while the outer layers swell outward. Immense convection currents churn through the star's atmosphere like boiling plasma oceans. Some of these convection cells may be so massive that a single one could span distances larger than Earth's orbit around the Sun. Imagine colossal bubbles of stellar fire rising and collapsing across the surface. That is Betelgeuse. Not a quiet sphere of gas, but a turbulent ocean of energy. And these giant convective motions can dramatically alter the star's brightness. But astronomers now believe something even more dramatic may be occurring. Betelgeuse could be entering one of the final chapters of its existence. Because stars like this do not simply fade away. They die violently. When a red supergiant exhausts its nuclear fuel, the balance between gravity and outward pressure collapses. In a fraction of a second, the core implodes. Then comes the explosion. A supernova. One of the most powerful events in the universe. For a brief moment, a dying star can outshine an entire galaxy. Shockwaves race outward at incredible speeds. Heavy elements are blasted into interstellar space. And the core may collapse into either a neutron star or a black hole. Current estimates suggest Betelgeuse could still survive for tens of thousands of years. Perhaps even longer. But the truth is, no one knows for certain. And that uncertainty is exactly what has captured the world's attention. Because if Betelgeuse exploded during humanity's lifetime, It would become the greatest astronomical event ever witnessed in recorded history. Visible in daylight. Bright enough to rival the full moon. Shining over Earth for weeks or even months. Human civilization has never observed a nearby supernova with modern technology. Betelgeuse may eventually change that. And lately, the star has been warning us that something inside it is changing. In late 2019, astronomers around the world noticed something extraordinary. Betelgeuse was fading. At first, the change seemed subtle. But within weeks, the star lost nearly 40% of its brightness. Even casual skywatchers could see it. The brilliant red giant that had dominated Orion's shoulder for centuries suddenly looked weak and dim. Speculation spread rapidly across the internet and scientific community alike. Was this it? Were we witnessing the final moments before a supernova? For a brief period, humanity wondered whether one of the brightest stars in the sky was about to explode. Observatories around the world immediately focused on Betelgeuse. And what they discovered was astonishing. The star had not simply dimmed uniformly. Parts of its surface appeared darker than others. Enormous clouds of gas and dust surrounded it. Something massive had erupted from the star itself. Later analysis suggested that Betelgeuse had likely expelled a gigantic plume of material into space. As the hot gas cooled, it condensed into dust that temporarily blocked some of the star's light from Earth. This event became known as the Great Dimming. It was not the beginning of a supernova. But it revealed something equally important. Betelgeuse is far more unstable and dynamic than astronomers once believed. The outer layers of the star are constantly shifting, erupting, and reshaping themselves. And the James Webb Space Telescope has allowed scientists to see this process in extraordinary detail. Unlike visible light telescopes, Webb observes primarily in infrared wavelengths. That means it can peer directly through dust clouds surrounding stars like Betelgeuse. What Webb revealed was breathtaking. Massive arcs of expelled material stretching through space. Uneven plumes of gas flowing away from the star. Complex structures forming in the surrounding environment. Betelgeuse is not quietly aging. It is actively transforming the space around it. Some astronomers now believe the recent brightening and dimming cycles may be connected to enormous convective upwellings deep inside the star. Others suspect intensified mass loss may signal changes occurring near the stellar core itself. And there may be another hidden force involved. Magnetism. Although magnetic fields inside red supergiants remain poorly understood, researchers suspect they could influence how heat and energy move through the outer layers. Localized magnetic activity might create hotter or cooler regions across the surface, producing dramatic fluctuations in brightness. The challenge is that Betelgeuse refuses to behave predictably. Every observation seems to create new mysteries. And this uncertainty is scientifically priceless. Because massive stars like Betelgeuse are responsible for creating many of the elements necessary for life. When they explode, they scatter oxygen, carbon, silicon, calcium, and iron across interstellar space. Those elements later form new stars, new planets, and eventually living organisms. In a very real sense, the atoms inside the human body were forged in ancient stellar explosions billions of years ago. We are made from the ashes of dead stars. And one day, Betelgeuse will join that cosmic cycle. Creation through destruction. Life emerging from collapse. That is the strange paradox hidden within stellar evolution. Astronomers now monitor Betelgeuse constantly. Tracking brightness fluctuations. Mapping surface motions. Studying dust formation. Searching for signs that might reveal how massive stars approach death. Some researchers believe stars may display warning signals long before exploding. If that is true, Betelgeuse could become the first nearby laboratory for studying a supernova before it happens. A real-time window into the final stages of stellar life. For centuries, humanity viewed the stars as eternal and unchanging. But Betelgeuse has shattered that illusion. It reminds us that even the brightest lights in the night sky are temporary, dynamic, violent, fragile. Whether it explodes tomorrow or 100,000 years from now, Betelgeuse has already transformed astronomy. Because it proved something extraordinary. Even the stars we think we know best can still surprise us.